If you want to land transactions really fast, or you or your VPS are located in Europe, this video is for you. My name is Benjamin, and in today's video, I will show you how you can land transactions extremely fast using our Amsterdam RPC services. In today's video, we are going to cover why using RPC node services located in Amsterdam might be beneficial and how to test landing times across different RPC endpoints. And on top of that, all the code will be available for download via our GitHub repository. By the end of this video, you will know how to test latency yourself and why Amsterdam might be the smartest choice. For more information, you can always check out our official documentation or join our great Discord community. Both links will be in the description, and with that said, let's get started. Alright, so what benefits does having a RPC node service in Amsterdam really have? To answer that question, we need to take a small step back. Every bot or application that wants to interact with the Solana blockchain needs to do that through a Solana RPC, whether that's through gRPC or WebSocket for real-time notifications or HTTP requests for on-demand state queries. In short, all these communications go through these RPC nodes to eventually reach the validator network. Now, why is that important? So, as we can see here, as of late 2025, Europe consistently holds the biggest share of staked SOL, around 70% of the total stake. Now, Frankfurt often hosts the most individual Solana validator nodes. Europe as a whole dominates the actual stake weight. And higher stake in Europe means more leader slots are assigned to European-based validators through the stake-weighted leader schedule. And also here we can see that most validator hotspots, just like the stake hotspots, are located within Europe, mainly within Frankfurt and Amsterdam. This pulls the bulk of block production, consensus voting, and gossip traffic towards European data centers like Frankfurt, London, and Amsterdam. This is why these low-latency European locations, including Amsterdam, remain optimal for performance-critical operations like trading bots, snipers, arbitrage tools, or dedicated RPC services. Now, physically being close to where the most blocks are produced first gives you faster transaction inclusion, better real-time data requests, and of course a competitive edge, often by tens of milliseconds, which matters a lot in the fast-paced Solana ecosystem. So now that we know why using these RPC services located in Amsterdam might be beneficial, let's check out how we can actually measure end-to-end latency between different RPC nodes. Alright, so for today's video and test, we are going to use a tool called MemoBench gRPC. And this is a benchmark tool to test the Solana transaction landing times. And as you can see here, it is a high-performance benchmarking tool for measuring Solana transaction landing times using Yellowstone gRPC for real-time transaction monitoring. Now, if we scroll down, we can see how it actually works. And here it says that we're going to use a Yellowstone subscription. And the tool subscribes to the Yellowstone gRPC for real-time updates about the transactions involving the test wallet. So we're going to use a test wallet and create transactions from there. As you can see here, we are doing that by creating simple demo transactions with unique test IDs, and they are being sent in a synchronized way. So all transactions start sending at the next 10-second mark for consistent testing. And then we are going to real-time monitor this using the Yellowstone subscription. So we're going to send these transactions, and then we use that Yellowstone stream to check these transactions, or we are going to see when they land on chain, and then we can get these real-time notifications. And then there is timing calculation where we will measure the delta between the send time and the landing notification. And then there is some statistical analysis that is done to output all this information within our application or within our console to see which endpoint works best for us. Now, by default, this tool does not support tipping or multiple RPC endpoints. That is why we are using a slightly modified version, which you can find on the multi-tip endpoints branch. So if you want to download the code, make sure that you switch branches so that you have the exact same code base which we will be using in this video. If you want to know how you can update the tool to include these tipping instructions, make sure to check out one of our previous videos on Lightspeed, where we used the same tool and covered in detail how we added that tip instruction to make sure that we could use Lightspeed. Now in this video, we are going to compare multiple RPC endpoints, one within Atlanta and the other one based in Amsterdam, which we will use using the Lightspeed network. And that's why we will use this version of the tool, as it includes multiple endpoints support and the tipping instruction feature. So with that said, let's jump into our code editor and start testing. Alright, so now we are in the code editor and I downloaded all the files from the branch that includes the changes that we want to have. Now, as you can see here, the first thing that I did is create a build folder and I put in the config.json file there, and this will hold our configuration. There is a config.json example which you can just copy, and of course you need to rename it without the .example at the end, and then you can also put it in the folder here called build. Now let's have a quick look at that file. So first we have to provide our private key, because that will be used to derive our key pair from, that we will use to sign these transactions. Next we have the RPC URL, which will be used not to send the transactions, but for things like fetching the latest block hash that we will need in order to create the transactions. Once we have the transactions, we are going to send them using these two send RPC URLs, and we are going to use a staked RPC connection that is based in Atlanta and a RPC connection which is based in Amsterdam. And for this we are going to use the Lightspeed network, and that's why we needed that tipping feature or functionality within the code base. Next we have the Yellowstone URL, and this is our gRPC that we will use to monitor real time when these transactions land. Then we can specify things like rate limit, transaction count, and for this video we are going to send 10 transactions for each RPC endpoint, and then we can also add things like tipping address and tipping amount. However, as we only want to tip this time for our Lightspeed connection, we can specify the URL that we want to tip for. And by doing it this way, our program will only tip for the URL that is specified here. And you can see we specify the tipping address, so the recipient, and also the amount of tip in Lamports. And I believe this is 0.001. So again, we did a dedicated video on the Lightspeed network. So if you want to check that out, the link will be in the description. Now, once you have updated the config.json file, you can cd into that build folder, and then you can run the following command. So you can see here, go build, we specify some flags, then the output file name, which in our case is memobench grpc.exe, and then we have to specify the main go file. And as you can see, this is also specified within the documentation. So if you want to just copy that, you can do so. You just have to make sure that you specify the right name, as it says here, without .exe, for example. As we're running this on a Windows machine, we want to have a proper executable file, and also we need to specify the proper location for our main go file. Now, if you run this on a Linux machine or a macOS machine, you don't have to specify the .exe file. Just in case, it is important to know that you have to run this command and build that binary from the go files on the machine that you want to run this tool on. So you don't have to build it on Windows and then copy that build to a Linux machine, because that might not work. So you have to build the binary on the machine that you want to run it. So once you have specified that, you can just enter, and that will build the exe file for us. And as you can see here, now we have a memobench grpc exe, and once we run that, that will start the benchmarking test for us, and it will look at the config.json file in order to see what information it needs to use and what RPC endpoints it needs to test. Alright, so now that we have our memobench grpc executable, the only thing that is left is to actually run it, and we can do that by typing its name like this and just press enter. Now, once you do that, you will get a nice overview of all the settings that were specified in the config.json file, as you can see here, like the endpoints that we want to test, the amount of tipping, and also the amount of transactions. Eventually, it will start send the transactions, and the gRPC connection will pick them up once they are landed on chain. It will take that information, process it, and output it for us really nicely within the console. As you can see here, we will get an overview of how long it took to land these transactions, a minimum, a maximum, and an average. average, how many blocks were consumed to send these transactions, but more important, the difference between the two RPC endpoints that we were testing. And here you can see that we have the staked RPC based in Atlanta, which took us on average 771 milliseconds compared to the RPC in Amsterdam using Lightspeed. There it took us an average of 148 milliseconds to send and land these transactions. Now, as you can see already from this result, it is more beneficial for me to use the Amsterdam RPC, of course, as I am located in Europe. Now, there are many more considerations to make to land transactions quickly. I'm running this locally on my machine. I could have opted for a VPS running in the Solana Vibe Station data center, or I could purchase a VPS close to any of these regions. As I said, there are many considerations to make once we want to land these transactions really quick. But from this overview, I can already see in my scenario, as I'm based in Europe, I would go for that Amsterdam location. So that's it for today. I hope you now understand that it might be beneficial to use our RPC services located in Amsterdam and how you can actually test this end-to-end latency yourself using this benchmark tool. Again, we post these kind of results in our Discord server, so if you're not there yet, the link will be in the description and we hope to see you there. And with that said, I hope you think it was interesting and I'll see you in the next one.